Okay, so now we're going to find the eigenvalues and corresponding eigenvectors for this matrix A. So I'm going to solve this equation where my determinant of A minus lambda I equals 0. So A minus lambda I is going to be 3 minus lambda, 0, 8, negative 1 minus lambda. That's a terrible lambda. And I want the determinant of that. So I'm going to end up with 3 minus lambda times negative 1 minus lambda minus 0 equals 0. So that implies that lambda is 3 or lambda is 1. Lambda is negative 1 from that second factor. Okay, so now I want to determine my eigenvectors. So we need to come back into our original setup to find our eigenvectors. So I'm actually going to move this down a little bit to give myself some more space. So now let's look at lambda equal to 3. So now we know that we can come back to this equation, and for lambda equal to 3, that means that this matrix, I'm going to plug in the 3 here. I'm going to end up with 0, 0, 8, negative 4 times some vector xy, or you could use x1, x2, whatever, equals 0. Well, of course, this top row is just going to be 0 equals 0. The bottom row, I'm going to get 8x minus 4y equals 0. That means that 2x is equal to y. So now we could look at x as our free variable. So we could say that our solution for this equation is that our matrix xy has to be equal to 1, 2, t, where t is an element of reals not equal to 0. All right, we could repeat the process for lambda equals negative 1, and I'm going to leave that up to you. You can go look at the printed solutions to see the answer.